Welcome, everybody. It is April 29th. We are doing our weekly STEM here at Expedition STEM. My name is Andrew.
And I am Chris, and thank you for tuning in. It's been a very interesting week full of rodents, space travel, clean energy, and all sorts of fun stuff. If you've been paying attention to our channel, you'll notice that we actually have a bunch of new videos that came up this week. I got frustrated editing all of these solar impulse videos, so I uploaded all of them in raw form, so you can watch every single one. And then Andrew, thank you very much for editing everything for me and compiling that down.
Yeah, actually, it's just one video now. So
okay, good. And then you also updated put a great video up there for your NASA Space Apps Challenge video. Very well done, by the way.
Thank you, appreciate it.
But it's been pretty fun. I know you've been working on that this week. What all's going on?
Yeah, just been busy with that. It was last weekend was the challenge, but this week we had to get everything ready to submit today for sort of like the national competition. Last week was just sort of local stuff. So making that video and sort of like cleaning up my code. Like I had I think 4 different software programs that I wrote for the project, and it was all messy and stuff. Like it worked, but it was like very messy to read. So I was cleaning all that up. So yeah, that's what I did this week. This weekend is going to be nothing but relaxing because I've been super busy with that Space Apps Challenge. Not that I didn't have a good experience, but it'll be nice just to relax. And yeah, next week I'm going to be driving through our old hometown in Maryland. To go up there for work for a couple of days. So
say hi to Rockville for me.
Yeah, we'll do. I don't have a place to sleep anymore when Mom moves, but yeah, I'll just be there for work anyway. So anything going on with you?
Well, it's been fun this week because I've actually been able to take on a couple of pet projects, one of which is actually working with a buddy of mine for a new IoT company that he launched that's focused on creating applications and control systems for nuclear power plants and manufacturing facilities and all sorts of really cool industrial applications for IoT. But really looking at how to do it more securely instead of just kind of the BYOD, the bring your own device to work kind of mentality. Now it's actually purpose-built applications that can run on consumer products but be more secure, more connected, and provide greater control. So it's actually a really cool company that I'm working on. Probably have an announcement about it coming up soon on once it's ready to go live. But
cool.
Yeah.
Can you show everybody your shirt? Like maybe just like set up a little bit.
There we go. So I am actually sporting the iZap Ducks, kind of a throwback to the old Nintendo. If you haven't seen the video of the Space Apps thing, we also got another throwback there. I'm sure Andrew will talk about it in a little bit in our tech segment. But you ready for us to go on to today's top stories?
Yes, sir.
Alrighty. Well, our first one actually comes from SpaceX, and is we look at more science and space exploration, continuing on the NASA theme. This week, SpaceX announced that they will be able to reach Mars hopefully by 2018, dramatically beating NASA to the punch. Their new Dragon I guess lander or capsule, which is already performed a number of landings here on Earth. They say we'll actually be able to get up and moving much faster than NASA can. Developing and privatizing essentially space and being the first ones on Mars instead of being a government agency or something that's state sponsored, but being a private agency. Andrew, I'm interested what your thoughts are in terms of the privatization of space travel and exploration. Should we rely on companies to do it? Should we have the government still having a hand in controlling it? What are your thoughts there?
I think that the government, has a lot of red tape. So not that NASA can't get there first, but they have to rely on the budget from the government, and that's always sort of like in debate. So SpaceX can basically do whatever they want as long as they can afford it. So I'm definitely down with the privatization of space flight. I probably wouldn't want to be the first one on a private space flight, but yeah, I think it opens the doors and makes everything cheaper. And hopefully one day, suborbital flights or even, deeper into space flights would be sort of affordable for, you know, every person, sort of like, taking a vacation with your family. Like you'd have to still save up for it probably, but you'd be able to do it. And I think all this stuff is helping I think SpaceX is also helping keep the cost down for NASA because, NASA doesn't have to do it by themselves now. So they have SpaceX to launch satellites and that sort of thing. So yeah, I'm definitely for it.
Yeah, I think it's interesting that the kind of how they've been continuing to increase their technologies and their successful launch and recovery of their launch vehicles, the rockets that they sent up the last time that sent the payload to the International Space Station. They've been testing their lander system or the Red Dragon lander for quite a while, and actually have had some pretty successful landings and orbital reentries of that product. And seeing how they've been kind of really pioneering the way, challenging the way that we're designing new technologies and what we can do and how to get people there faster. I think it's great. I mean, at some point we want to get off the rock, right? We want to get off of Earth here and continue to explore, the boundaries of space and what the possibilities are. And given that Elon Musk and the SpaceX teams and people have set forth a vision that is not only driving their technical innovations and products that they've created, but how it's influencing even government agencies, whether it be the Russian or European or even the NASA space agencies, but influencing how quickly we can somebody do it. It actually kind of reminds me, even though we weren't alive in the 60s, but at the beginning of the space race, when we said we would put a man on the Mars, or a man on the moon, and within a few years we had the Apollo program up and running, and now private companies are saying we want to put a man on Mars, and it's kind of that same furor or same fury and hustle to get technology developed that can get us there faster.
Yeah, I'm wondering what's in it. How is SpaceX maybe making money on the Mars mission? Because I get, when they send stuff to the space station, they're making money, like they're delivering a product. But I'm wondering how they're paying for their Mars trip. I mean, it'd be cool if they just use their profit or whatever, but I'm assuming it's going to be very expensive.
Well, I think the first way that they have to do is proof of concept. They have to prove that they get there. They have to be able to prove that they can safely land and re-enter. I know that when NASA sent was it the Curiosity rover in 2012, just landing on Mars was called the 7 minutes of terror because of how crazy the engineering had to be to get the landing to work. So yeah, I remember even before that we had NASA cratered just completely cratered a payload that went to Mars because somebody mixed up feet and meters.
Yeah, I think recently back in the news again, because I forget what that probe was called. I'm not sure if it's the same one, but they just had recently in the news that they found some sort of probe on Mars that was like flattened like a pancake or whatever, and they were able to image it. I think it was that one.
Yeah, it'd be funny if they found a pancake. But I think that these first couple of trips that they're going to be able to send something to Mars by 2018 really will be the proof of concept. And then from that point on, it'll be kind of commercialized space travel, not necessarily people, could be people, but maybe complete payloads in order to get ready for a manned mission to Mars. One of the things, if you remember in the movie The Martian, they had sent the MAV and the HAB and all the materials ahead of the actual landing crew. So being able to have somebody that has the proven ability to send things to a pinpoint location on Mars, the specific landing area, then you've opened up the door for commercializing, getting the payloads there and preparing for a manned mission.
Right. All right. Well, next we're going to talk about technology. So this week we're going to talk about the project that I worked on for the SpaceX challenge with a couple other guys. The link's going to be below so you can see all the detail there. But the technology is more of an old school tech meets new school tech, and it is hacking the Power Glove. So if any of you don't know, the Power Glove was a piece of 1980s tech made by Nintendo or Mattel, or Mattel for Nintendo, and it didn't really catch on. Like it looked pretty popular, like in terms of like, oh, that's cool. It was featured in the movie The Wizard, and I forget his name. I think it was Lucas that had the Power Glove. He was like, it's so bad, it's like one of the famous Power Glove lines. But so yeah, for the project, I hacked it, and so yeah, I'm gonna talk about that. So originally, this Power Glove, the way that it sort of like was a controller was it used these things up here. They're called ultrasonic sensors. It's basically sending out a pulse of sound and then sort of like receiving it back. But there was also like an array on the TV that you had to put up there, and it would sort of sense sense the signals and sort of get your position of your hand. And then also in the fingers were bendable sensors, so it could tell you when you were squeezing your hand. So depending on what game you're playing, you would put it into a different sort of programming mode with these top buttons here, and you would do certain gestures to perform certain actions in games. So with the Space Apps Challenge, we entered a category where we had to create a wearable sort of piece of technology, and we sort of got onto the topic of making a glove. And I was like, hey, I got a Power Glove and I want to hack it, so I did that. So some things that are different that I did, well, as you can see right here, there's no wires connecting this thing, so it is wireless. That's one cool thing. And it has a LCD screen right here, a little speaker, and it's got some different tech in the hand. I left the ultrasonic sensors there, but there's another piece of tech in there, and I think, Chris, you had a question about that.
I mean, I was more curious, it comes embedded with a bunch of sensors in terms of opening and closing, but I know like with phones and other technologies, there's the gyroscope or gyros built in, as well as accelerometers. Like, did you hack it by adding some of those sensors? Did it already have some of them?
So the only sensors that I had was in the fingers when until you could bend them, and these little ultrasonic ones. So as you said, the accelerometer and gyros, those are used like in phones and other things to sense motion and how you're holding your phone, that sort of thing. That's what these ultrasonic sensors did. It could only sense in two directions. It could sense movement like this and like this and like this. So it could sense roll and yaw, but it couldn't sense pitch. That's basically because you're not changing your direction that way, but you are changing it sort of here. They're kind of offset and like anyway. So definitely that's way old school tech. The accelerometer and gyros are definitely in the new school tech, and I put in what they call a 6-degree of freedom sensor in there. So it has a 3D accelerometer and a 3D gyroscope in there. The only sort of thing that a 6D chip is missing is a compass. That would be like a 9-degree of freedom chip if you had a compass on it. But for this purpose, not too necessary. And they cost a lot more than just a 6-degree thing. I think I got this thing for like $5, the chip that's in there.
Okay.
So yeah, so it senses your movement, and we'll see a demo of that in a little bit. And yeah, so let me turn it on, and I'll try and hold my microphone up to the speaker to see if you can hear this thing turn on.
Sorry, I got to give you a little theme music for
it. Yeah, so it's on right now. One of the other extra things it has is this little heart rate sensor. So it's kind of like the ones that are in Android phones. You like basically hold up your finger to it, that sort of thing. So I'm going to put it on. And by the way, this is powered by a microcontroller called the Arduino. If you don't know what Arduino is, it's basically like a little tiny computer. They come in all shapes and sizes, but this one's super tiny. So it's basically controlling all of these functions. So right now I have this little robot behind me, this little robot arm. So I hope everything behaves so I can demo this. Let's see. So I should be able to connect, and let's see. So if I move my arm that way, you can sort of see the robot arm moving and move it back. And then if I roll my arm, you can see the sort of grip sort of rotate. And then if I squeeze my hand, then it'll squeeze the little grip there. So it's a little laggy. This thing like isn't like that's a little easier to see, I guess. It's not the most perfect robotic arm right now. It's a little laggy, but you know, it serves its purpose.
So now all you need to do is hack a hoverboard to go along with it, and get all sorts of Back to the Future and Nintendo, and just slowly bring 1980s to Mars.
Yeah, I wish I could hack a hoverboard. That'd be cool. And then I don't know if you can see it very well, but yeah, probably not. But you can see the little heartbeat sort of monitor on the screen. I think the brightness might not be up as much, but so yeah. So for our project, we got to control this arm. We also had it control, basically provide input to a computer. And it's using this little radio right here. It's called a NRF24L01 radio. It's just basically like a little sort of wireless device. So that's the thing that transmits your messages back and forth. And yeah, it was really cool to work on this project. I love doing this. There's definitely some things that I'm definitely gonna make another one, by the way, so I can sort of do a tutorial on it. And there were some things I learned from this one that I can improve on the next one. I'm gonna be changing the wireless radio to Bluetooth, so it can be sort of more easily integrated into other devices. I might try and do the 9-degree freedom chip in the glove. And I'm going to get rid of this screen. I mean, it's cool that it's there, and there's like the speaker here, but I'm going to try and just make those smaller so it doesn't weigh as much. So yeah. Check out the video and everything below. Check out our project.
Well, I was going to say, tell us a little bit also about the mesh networks, if you can. I mean, one of the things that you said in there was how devices can talk to one another, or how it's all working. So, kind of give us a rundown on like what are some of the limitations, or how do we really get it all as a integrated system? What's your vision for it?
Yeah, so the project that we worked on, it was called FractalNet, and for the Space Apps Challenge, it's not like you had to come up with an entire solution like that weekend. You sort of like, develop your idea and that sort of thing. But yeah, our solution was basically to confront the issue of line of sight communication when you're like in like a cave or something. We were talking about asteroid mining. So if you're in an asteroid and you're doing mining, if you can't see the other person that's in the tunnel, like you probably can't communicate with them on the radio. So FractalNet is basically like a network of relay nodes that help transmit data through through the entire network. And there's different devices on the network as well. So you have your data glove, you have a server and like your astronauts and that sort of thing. So the data glove is meant to be sort of like the human interface with the network. So when you're setting up these nodes, you would be doing it from the glove. And when you're controlling robots, like as you saw, you can like control robots. You can do a whole lot. There's a lot of different things you can do with gestures and that sort of thing. And one of the other features that we built into the sort of thing, or that we haven't really physically implemented yet, but as you saw, like I had my heartbeat on here, that information is being transmitted along with other things. So on the server, like if I had the server up, which I can't because it's on my computer that I'm using to film this, you could see my heartbeat there, and that information can be transmitted to other astronauts. So one of the really cool things is that not only can you use it for communication between astronauts and that sort of thing, but if one of your astronauts like is sort of getting sick or something, like the idea is like you can see their vitals on your glove. So you know, in our video, we sort of simulated someone falling and sort of getting hurt and their heart rate going up, and so the other astronaut is looking at a screen saying like, "Hey, you're all right," you know, like saw your heart rate going up.
So is that science influencing the movie The Martian, or is it the movie The Martian influencing you guys in terms of some of the additional capabilities of hacking the Power Glove?
Yeah, there's a lot of influences. The Martian, you know, they left Matt Damon on Mars, right? Because they thought he was dead. So one of the things we were talking about that a sort of like data glove or some sort of vital thing could do is sort of not just provide a. They thought he was dead because well, he got blown away, and then like you know.
Well, his monitor wasn't transmitting, so they had a loss of signal on his bio monitor. They were getting no biofeedback.
Right.
So I mean, I you know, I saw that and I said, you know, you totally stole that from Matt Weir. Yeah. So.
Oh, I mean, like yeah. So like yeah. So one of the things is not only would you check on the astronaut's health, but we also thought about like, yeah, if you were to somehow become disconnected, it doesn't mean that you're dead. Like you would hopefully get some sort of message that says, I'm not dead. Like it's like at the hospital where you have like a little thing on your finger and like, you know, if you take it off, you go flatline or something like that. Like the machine in the hospital doesn't know if you're dead or alive. It just knows that it's not getting a heartbeat. So hopefully there could be some sort of like thing integrated like that where there would be some sort of like message broadcast to say that, hey, I'm just disconnected from the network. Doesn't mean I'm dead. Because yeah, his bio stuff got torn off. So, you know, maybe, yeah. So if I tore off this heart rate sensor, you'd see no heart rate. But there could be other information that's not being transmitted as well to sort of give you a clue as to the real situation. So yeah, I can't wait to hack this even more or make my other ones. I think I might leave this one how it is, and I already bought another one, so I'm probably gonna hack that one. Planning to fly with my quadcopter. Might be a little tricky. It might be very, very touchy. It should be easy to implement, but it just might be sort of hard to fly it.
Do you have the Parrot AR drone?
No, I got well, I have
DJI.
Yeah, I have the Phantom, but I'm definitely not hooking it up to $1,000 quadcopter.
I don't recommend it. Well, I do know that Parrot has an open API for any Parrot drones. So if you have a Parrot drone or access to a Parrot drone, they have a full software development kit and API so that anybody can connect their own apps to it. So it might be easier for you to use any of the Parrot products for that.
Yeah, I have a $60 drone that I'd be happy to
trash.
Yeah, I've flown that thing on the walls and it still flies. So, yeah. So yeah, that's our piece of tech is old school meets new school, and yeah, look how cool that is, man.
Well, our engineering story actually still takes us along the lines of some flying things, not drones though. It's actually inspired by the Solar Impulse 2. It was, if you saw the video, it was the world or the solar airplane that is traveling around the world. It's actually took off from Dubai, made it all the way to Hawaii last year, and spent the last 8 to 9 months getting repairs for some of the battery issues. It wasn't charging, so they had to land in Hawaii for a very extended trip. But pilot Bertrand Piccard, not Captain Picard, but Bertrand Piccard, made his way to Moffett Airfield this past Sunday. And the guy was super, super energetic when he got off the plane. I mean, he'd flown for 2.5 days straight and still had enough energy to come out bounding out of the cockpit. And provided a really interesting a number of statements to press and as well as everybody that was in attendance about the future of renewable energies. And either the guy is drinking a lot of Kool-Aid or he's just that passionate about how renewable energies and the renewable future are not just theory, but the Solar Impulse 2 actually provides more of a what's the word that I want? It qualifies or actually shows you that there's a real possibility. It makes it real, validates the trip. That's what I want to say. It's now a validation that solar can be a mode of transportation. Granted, at 35 miles an hour, but the renewable energy future to get us off of fossil fuels and other carbon emitting and CO2 emitting products or greenhouse emissions is a possibility. So, my question to you, Andrew, there's actually a recent documentary that showed how it was actually aired this past week on HBO on the free weekend. And if I can find the link to it, I'll send you. But what do you see as the future for renewable energies? What's it really going to take for us to get a renewable future? And what types of technologies do you think are actually going to lead the way in terms of sustainability? Is it wind, solar, fusion? What do you think about renewables?
Yeah, I mean, so I think it's going to take a long time to sort of get everybody on board. There's a whole lot of bureaucratic sort of stuff going on with the subject matter, and I think just the sort of debate with climate change is sort of like a lets people know like how difficult it's going to be to move to renewable energy, because yeah, we do it a little bit right now. There's some people that are living off the grid, but in order to sort of get the country to live off the grid, it's going to take a whole lot of politics and things like that. And so hopefully that happens sooner than later. Hopefully people will eventually believe in scientists. I think it's funny how they don't mind using a cell phone. They believe in their cell phone because it works, right? They go on Facebook and they call each other, that sort of thing. But, they don't trust scientists who are climate experts.
Right.
So it's like, that always bugs me. But yeah, in terms of like what renewable sources would be the most beneficial, I think it sort of depends on where you live. Obviously, like, the weather's a huge factor in solar and wind, and there's some wind farms, in certain places where there's not solar, and there's some solar places where there's not wind. So there's actually I think solar is good because you don't have any moving parts, and you just put a piece of square tile outside. Obviously, when it gets cloudy, you probably need some sort of other sort of energy. But if you can harness like 100% of the light that hits the ground, like that's still a lot of energy. Solar panels are not very efficient right now, so if they can perform better, that would be awesome. Wind, I think it could be used how it sort of is now. I don't really see anybody having one like at their house, having a turbine. It's just a little too big and that sort of thing.
Unless you live in like Holland or someplace where you're also like milling grain with a windmill or something like that.
Yeah, if you live at like a putt-putt golf course, maybe you already got a windmill. And yeah, I think a lot of people are against nuclear, but I think nuclear, if we can do it right, it provides, it's clean burning, right? Like it doesn't really cause any sort of pollution. Just if like the stuff spills, then that's the bad part.
Right.
But
well, I mean, so you're touching on a bunch of things. Weather's always going to be a thing for most of the renewable sources, solar and wind. You look at the solar farm that's in Las Vegas, actually, that pilots are complaining about because it's so bright in terms of the reflection. But it's actually one of the most efficient solar fields that are created because they have a central collection tower where everything's actually getting reflected back to that central collection tower. So it's a much more efficient solar system than the ones that you would have on everybody's house. Wind is something that per kilowatt hour is actually killed more people in the development of the technology than any other energy production that includes coal, that includes nuclear. More people have died per kilowatt hour of manufactured energy building wind turbines than anything else. And I think the politicians who want to obstruct wind power are also idiots. The ones that sit there and say, well, what happens to the air when you disrupt it that more? Well, or it's going to impact the wind in one place or another. I think those are just, some things that we have to overcome. You're right. We have to start listening to people. Nuclear is one of the ones that I think is really interesting. Current nuclear power, the problem with nuclear power is not the burning of the reactors and the operations of the reactor. It's the spent fuel. It's the storage of the spent fuel. One of the biggest initiatives up in Hanford, which was the home of our armament, the home of our nuclear arsenal, making all the uranium and plutonium that we did for the United States' reactors. Much of the cadmium and uranium, depleted uranium and other materials that came out of that are being stored in big old steel tanks that are now leaching into the Columbia watershed. So long-term storage is a problem for nuclear, for spent fuel, not for the active fuel, but for the spent fuel.
Right.
And there's been a lot of things, people, you think nuclear power, you think Fukushima as of recent. And there's, you talk to like my friend who works for a nuclear company, nuclear safety control company. There's no way possible that another Fukushima can happen to any other reactor anywhere in the world. And because of all the fail-safes, all the stuff that they've learned from Fukushima, in order to prevent a major catastrophe like that in operation. So I look at the future for right now. If we're to go for a carbon-free future, has to be looking at nuclear. Fission is the way that most reactors work today. And fusion is something that I think has shown a little promise. Actually, German Chancellor Angela Merkel, who most people may not remember, actually has her doctorate in physics. She was the one that turned on a German fusion reactor, which actually the first time in their tokamak reactor created plasma, which is the first step to having sustained fusion reaction, which is really just a huge step for having clean burning nuclear with no spent fuel at the end of it. So that's something that I think is a real interesting future for us. Actually, the Livermore lab around the corner from us here in Silicon Valley, or across the valley for us, they actually have the largest fusion reactor here in the United States in their research facilities, trying to actually use lasers to pinpoint, have one big reaction that goes into a single kind of cell. It's actually the reactor that was used in the Star Trek movies, the new ones with Chris Pine. When they show the engineering deck, they actually use the Livermore lab for that, which is an interesting fact I learned from that documentary. But if we can get on to at least getting more people to do what they can to get themselves off the grid, to get themselves off of focused on or less reliable on fossil burning fuels. I think that's going to be the biggest step, and that means our e-cars, that means our homes, that means getting off of gas heating if it's less efficient than other options, and doing whatever we can to reduce our own carbon footprints. You're doing what you can with your Prius. Thank you.
You're welcome. Yeah, no, people. A lot of people like live in the moment and that sort of thing, and like, there's plenty of oil or whatever. There's a limited amount. I mean, there's a lot there because humans are the first one to sort of dig it up, but there's only so much oil. So there's gonna be a time when we're gonna run out. So we definitely have to find some sort of alternative.
Well, and we got to fight the economics, right? I mean,
right.
gas or oil is $38 a barrel, whereas, getting, which means the price of gas is super, super cheap for us. And then you look at other costs, other fuel expenses or e-vehicles that, the newest Tesla starts at, was it $36,000? Yeah, $36,000, I think, for the base model on the Model 3. But there's other cars that are starting at $23,000 and they use regular fuel. So are people willing to pony up on the front side in order to get an e-vehicle and reduce their carbon footprints, or do they just want to pinch pennies where they can? And even if not having to pay for gas is going to be better in the long run.
Right. And I'm really glad like Tesla's doing a lot of these things, especially their I forget what they call it, but their battery for your house that powers your whole house. I can't wait for that technology to really take off because one of the problems with people that have solar panels on their house right now is like, I think they might be able to store a little bit of the energy, extra energy that is produced, but not enough at all to sort of like power your house at night or for multiple days or something like that. So, integrate solar with, a Tesla home battery. That'll be really cool. And, for all the haters of nuclear energy out there, but love solar, where do you think the solar energy comes from? It's a big star, in the sky that's called the sun, and it uses.
It's a giant nuclear reactor.
And those that don't know the difference between fission and fusion. Fission is when it's like the atomic bomb. It's when you blow apart the atom, and that's how you release the energy. Fusion is how the sun works, and they fuse atoms to make new atoms, and due to physics, the new elements that is formed, like when you put two hydrogen atoms together, you get helium. That like it weighs a little bit less, or there's like less mass, so that extra energy that was in there has to go somewhere, and that's released in the form of energy like that. So that's how we get all our energy from the sun. So yeah, go nuclear.
Woo!
Yeah, can't wait till it's actually fusion like powered stuff. That's pretty cool. It's you're not blowing stuff up but yeah, you need it's really hard to do it. Like obviously they've already done fission, but it's really hard to do fusion unless you're a star. It's really easy for the sun to do it.
Right. Well, I mean, the first steps in being able to create plasma is awesome. I think that's the first step. It's the sustained plasma where the reaction becomes a chain reaction and continues going instead of having to be kickstarted every time. That's when we're going to be able to have sustained, fusion and free energy as it is, or what the perpetual energy, where it's constantly creating itself. If you remember the movie The Saint many years ago with Val Kilmer. And one of the things of that movie was actually the idea of cold fusion, which is just science fiction at the moment. But it was this idea of having free, sustainable, perpetual energy that can be created from water, and just the reactions that happen from water. And if we could do something that, we've got a ton of water here. We got a ton of hydrogen, helium, and oxygen, and the basic elements, of life. If we can use just basic elements that don't have an impact on our environment when we create energy from it, I think that would be really cool.
Yep. All right, so we're going to move on to math. Everybody loves math. So I was trying to think of what to do for math this week, and I got something that is sort of educational that I had to apply when writing the code for my Power Glove. Now, this particular sort of thing isn't in my code yet for the Power Glove. It's I have like a separate code that's used it. So there's a.
So essentially, you don't want people to steal this yet.
No, it's just I haven't built it into the Power Glove stuff yet because I've been so busy trying to get other parts of it to work that I didn't have time to do this part. But I did wire everything to make it work. Okay, so the Arduino, the little microcontroller that's in the Power Glove, it has about 20 pins that I can use for input and output. So when I bend my finger, that's an analog input because it's gradual and that sort of thing. I can tell how much I bend it. Okay, so by the way, the Power Glove didn't have a pinky sensor. That piggy went to market, I guess. But so 4 pins are automatically gone using my fingers. Okay, the IMU or the accelerometer gyroscope combination thing, that thing takes up, I think, 3 pins, and there I've got like the ultrasonic sensors in there; those take up 2 pins. The text-to-speech module, that thing takes up a couple pins. The heart rate sensor takes up a pin. The LCD, I think, takes up 3 or 4. And then there's other things that just need to be sort of wired because of what I'm doing. So pretty soon, if you want to do a whole bunch of crazy stuff, you sort of run out of pins that you can use. And one of the things that now, I'm not going to say that I was the first one to hack the Power Glove. I'm definitely not. And there's definitely some other people who have done it and done it really well. But one of the things that I have not seen yet, I've only seen a few Power Glove hacks online, is having the entire button panel integrated into the glove to use. One guy, I completely didn't even use the buttons. And another one, he just used the bottom row. But if you have the buttons, why not use them? Well, like I've said, I've already taken up over half my pins of the things I've talked about. And if you count the amount of buttons that are on this thing, you have, let's see, 12 in here, and then you got another 4 for the D-pad. So that's 16. So you got 21 buttons on the Power Glove. But if you only have 20 pins on an Arduino, how do you make everything work? Well, it turns out there's this sort of trick you can do with electronics. You can't put more pins on the Arduino, but you can use the pins for multiple devices less often, that sort of thing. You're basically sharing pins. So there's this chip in here. Here's the Arduino right there. It's kind of hard to see, and there's this chip underneath it. I got all this duct tape on it, so it's hard to see. But it's called a multiplexer or a demultiplexer. This one functions as both. So what a multiplexer does is basically allows you to sample more data or deliver more data using less pins. And it does that because it's not sampling everything or delivering everything at the exact same time. It's taking turns talking to each thing. So, but it does it so quickly that you don't even notice. So, like some of the LCD screens that you'll see, like with the scrolling text or whatever, you know, if everything were assigned to it's an individual pin, like you would probably never be able to build that affordably. But if you use a multiplexer, you basically switch between these pins so fast that the human eye sort of can't see it. So you're switching pretty fast. So I was able to tie in that multiplexer and get more pins. So for 4 pins on my Arduino, I get 16 pins on the multiplexer. So I think that's pretty cool. You can sample up to 16 things only using four pins, and you could theoretically have you know, 4 of those, 4 or 5 of those multiplexers. So you're sampling like huge amounts of things. But some things you don't want to share pins. But buttons on the Power Glove is definitely something you can sample because it's happening so quick. By the time you press the button, like it's not like you're just like pressing it really quickly, like you're pressing it down. It takes sort of longer for you to do that than it does for that chip to cycle through. So this is kind of like the illustration of that chip. Don't worry, I'm getting to the math part. So you basically have like these pins on the top, and like you put your power over here, and then you have your 4 sort of control pins right here that are tied to your Arduino, and then you basically have your signals. So these are what you're commanding it with, and this is sort of the response back, where you're getting these 16 pins down here. Okay, so one of the interesting things how this works is how do you tell the code or this chip which pin you want to talk to? So, you know, how do you just say, oh, I want to talk to pin 10. What's pin 10 say? How do you tell this chip that? So it actually uses binary code. So here we got to our math, binary. So we have four pins and 16 addresses down there. So you can get basically 16 by using binary with 4. So for those that don't know a whole lot of binary, this is kind of how it works. So we're all familiar with the base 10 scheme of numbers. So like I have $1 and 10 cents. Those are using base 10. Binary's a little bit different. So instead of using 10 as your base, using 2. So in a base 10 system, kind of looks like this, where you have 10 and then 0, 1, 2, 3, where 10 to the 0 is what, Chris?
Oh, I am muted. I said 0.
10 to the 0 is what?
0?
Anything to the 0 is 1. All right, 10 to the 1?
10.
10 to the 2?
In this case would be 20, but no.
10
100. 100.
All right, maybe I should stop asking you questions.
Yeah, I'm still in Hawaii time.
Yeah, we'll go with that. And 10 to the 3 is 1,000. So you can basically write any number if you keep going. And base 10, you basically say, okay, well, if you want the number 5, how do you say that? It's basically 1 times 5, and then it gives you 5. And if you have 50, that's 10 times 5, and that gives you 50. And if you want to do 55, you know, you do one of each, sort of that thing. So binary is basically the same thing. So you have, instead of 10, you have 2. So it's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and so on. So how do you write the number 1 in binary? Well, binary, now if you remember, or if people don't know, in binary you can only use numbers 1s and 0. You can't use the number 5. There's no number 5 in binary, only 1s and 0s. So you can basically write any number in binary by just using 1s and 0s, and that's why sort of like you can relate binary to computers, because that's how computers talk. They talk in binary, even though you might program in some other sort of language, it's always converted to binary. And that's sort of because of sort of like this logic that goes into computers. ones and zeros you can think of like on and off, and you're controlling the switch, that sort of thing. So 2 to the 0 is 1, 2 to the 1 is 2, right? But the way you would write 2 is just the number 1 here. That means you have one of these things. And then so if I say one of these, that's in base 10, that'd be 1, that'd be 2. 2 to the 2 is 4, and that's 8, and that's 16. So if you want to write the number 5, you need to basically make a combination of these numbers in order to make a number 5. So, and you basically want to choose like the smallest combination of numbers to make your numbers. So I can make a 5 if I had a 4 and a 1. Okay, so I need 1, 1. I don't need any 2s, so I put a 0, and then I need 1, 4. So that's how you write 5 in binary. It's just 1, 0, 1. In base 10, it looks like 100 ones, but in binary, it's only 5. And then, yeah, you would keep adding stuff to get bigger numbers. So going back to my diagram here with that chip, we have addresses. We have 16, but like a lot of computer code starts with the number 0, so I have 0 through 15. So if I want to tell my code, hey, what's going on with pin 5, I send these signals to these 4 pins here with not 1s or 0s, but it's basically like high or low. But like I said, it's like almost the same thing. So if I send it to pin 5, I would make S0. I would send that a high signal, so that'd be 1. S1, I would put a low signal for 0. S2, I'd put a high signal for 1, and then S3, I'd put a 0. And so this chip converts that binary into, pin 5. And it's like, okay, well, now I'm going to let pin 5 go through here. So whenever you want to sample one of these pins, you have to write it in binary. So I don't think I've ever really had to program in binary before. But I had to test out my chip to make sure it worked and that sort of thing. So I had to, make sure that I was sending these binary codes to this chip to sort of get what I want. So I thought that was interesting. I thought it's related to math, and sometimes you don't always expect that you have to ever use binary, even if you do a lot of nerdy stuff. But here we go, using binary. So I guess I'm trying to think of a question to ask you, Chris.
If it's about binary, I'm going to be lost. It's been it's been over 20 years since I've had to do anything binary.
Yeah, I don't know when I say binary, what's the first thing that comes to your mind?
There's 1-0 type of people who know binary. Those who do and those who don't.
Yeah. See, so he already knows binary. So yeah. So for those who aren't visualizing the joke right now. There's like a T-shirt or something that says, people say like, oh, there's 2 types of people, blah blah blah. And binary, or like this binary joke, it says, it looks like this. There's this many people that understand binary, those who do and those who don't. So people who don't know binary would read that as 10. But in binary, remember this is your 1s and this is your 2s. So it's 1 times 2. That's your 2. So it's just saying that there's 2 types of people, and that's why it's funny.
Yeah, and apparently there's 3 types of people that can count: those who can and those who can't.
Yeah, and shout out to National Instruments. I'm wearing my LabVIEW shirt. Part of the project that I did for Space Apps was in LabVIEW, so it's pretty cool programming. Speaking of programming, LabVIEW is a very different kind of programming. Most people think of programming as like, sitting down at your keyboard and like hacking all this stuff out. LabVIEW is a really easy to learn programming language. It's mainly used in the engineering and industrial applications to like sort of monitor instruments, but it's a graphical programming language. So it sounds a little weird, but you have to like check it out. Basically, you take like these like blocks, like you can almost think about like building Legos or something. You take these blocks and you connect them together, and each one has like a purpose, and you can like specify certain values for certain things, but that's how you program in LabVIEW is these little blocks. It's almost like sort of like a flow chart or something like that. And it actually teaches you, or at least it taught me, like how to think about the process of the way things are done. And I think if you're a computer programmer, like you probably have a pretty good sense of that anyway, but it's just visual, and you can see like all this information at once. So yeah, if you're into computer programming and you don't know LabVIEW yet, check it out. I think they got some sort of like an expensive piece of software, but if you're into if you're like in a class or something, I think you might be able to pick up the student version for pretty cheap, or they might have a trial one for a month. But yeah, so that's all I got for math. Looking forward to traveling in Maryland next week, and then I think the week after that, Chris and I are both going to be in Phoenix. What are we doing there, Chris?
So the Intel Science and Engineering Fair is going on. So we will be there to talk to the smartest kids on the planet, and some of the inventions that they've come up with, or at least the smartest ones here in the United States, and some of the inventions that and scientific discoveries that they've made along the way. Some of it's are I mean, last year's was just incredible, the way that they used machine learning for cancer detection and other heart problems. Some of the other ones that I remember high school for us, I was researching whether or not there was a Pfiesteria outbreak in Rock Creek Park, and which turns out there was. But there's a lot of interesting, things that kids are just inspired by the things that are around them, and how that they can either invent something that makes their lives easier or better, or interesting applications of the things that they interface with every day. And a number of the things that they're inspired to do by their teachers. So I'm excited to go see what people are coming up with, the new ideas and the new frontiers, and the kids who are much, much smarter than I am.
Yeah, I was just going to say, it's going to be funny to interview people that are like, half our age and like way smarter than us. Looking forward to looking dumb on camera. Yeah, hopefully I'm going to try and have my, I might try and have my, my quadcopter hooked up to my Power Glove by then, so maybe we can go fly it in some open space. That'd be cool.
Yeah, it'd be fun to take some cool videos. I know we both got some other projects that we've been working on. So if we can get them to come to life while we're there in Phoenix, we'll try to do something with that. Maybe there's somebody else that we can see in Phoenix. I don't know. We'll look around the Phoenix area. If you live in the Phoenix area and you're watching this and have a thought of something science, technology, engineering, or math related that you want us to check out while we're in town, let us know. We'll try to make some arrangements.
Yeah, we'll be there from May 11th to the 14th.
Alrighty. Well, I think that about does it for today's show. Again, thank you for tuning in. If you haven't subscribed, please click the subscribe button thus far. Be sure to check out our website, expeditionsim.com, and subscribe to this podcast on iTunes, Stitcher, or your favorite podcast listening site. It is now live on Google Play as well. So thank you, Google, for finally getting your podcast things up and running. If you don't have the podcast option yet on Google Play, yell at them. They're rolling it out slowly, but it'll be there.
Yeah, like marshmallow. Like,
yeah, pretty much.
Finally got it. All right, well, we'll see you next week. Have a good one.
Thank you, guys. Take care.